In this video, let's have a look at division of polynomials. What is a division of polynomial? We are already familiar with division of polynomials, but we have not done in a rigorous manner, and we don't know all possible cases that can occur while considering division of polynomials. That is why it is important to look at division of polynomials. We know some cases, like for example, if I have been given a polynomial, say a2x square plus a1x plus a naught, and if I am told that if this polynomial is divided by a constant, say c, then I know what is the resultant polynomial. It will be a2 by c x square plus a1 by c x plus a naught by c. That will be the polynomial. So this case we are already familiar with. Now let us go to one more level of extension. Suppose this polynomial is divided by a monomial. That means we are considering a division of a polynomial by a monomial. Monomial means the polynomial that contains only one term, only one variable term. So in that case, let us take this example. So 3x square plus 4x plus 3, which is divided by x. Okay, so notice few factors here. In this case, when I am considering a division of two polynomials, the numerator and the denominator should always have a degree smaller than the degree of the numerator. If it is not the case, let us say the numerator has degree m and the denominator has degree n, then what I am saying is the degree of the numerator m should always be greater than or equal to n. If it is not the case, then the division is not possible. Okay. For example, let us consider one case where I am considering a constant polynomial, let us say 4, and I am dividing it by some polynomial which is 2x plus 1. Here I cannot divide this polynomial, I cannot divide by this polynomial because there is no corresponding x term. Here it is x raised to 0. So I cannot divide this polynomial because the degree of the polynomial plays a crucial role. So in this case, the division is not possible. I have to keep this function as it is. Let us keep this point in our mind and consider division of polynomials. So now I am dividing a polynomial with a monomial. How will you handle this? So a monomial is simply x here. So what I will do is I will split this with this addition sign. I will split each of them in separate terms. So I will consider the term 3x square by x. That will give me a term. When I consider this term, it will give me a term 3x. When I consider 4x by x, I will get a term 4. Now as I mentioned earlier, when I consider the term 3 by x, the degree of 3 is a constant polynomial. Because 3 is a constant polynomial, the degree is 0. So I cannot divide this polynomial. So this will automatically influence this decision that it will remain as it is, that is 3 by x. So these are some key things while dividing polynomial by a monomial. Now the key idea is I want to divide a polynomial with another polynomial. Let me erase this first. So now I want to divide a polynomial with another polynomial. So how will I go about this? That is, I want to find something of this sort. Let us address this question in a video. Okay. So apparently I don't have any practical way to divide this right now, but from whatever theory I learnt about quadratic functions, can I derive something? That's what the question is. So we will try to figure out some more methods in this video. So let us continue and take a question. This is the numerator that is given to me divided by another polynomial which is x plus 1, and I want to figure out what this will be equal to. Let me take this polynomial over here and try to figure out what this polynomial will be equal to. So now I have 3x square plus 4x plus 1 and it is divided by x plus 1. Now if I want to divide the numerator by the denominator, what I should see is, okay, the denominator has the highest degree, which is x. The numerator has highest degree, which is x square. And now how will I be able to get rid of the denominator for some, at least for some terms? So in that quest, what I will see is, I will simply take the first term over here and the first term over here, and I will see, like monomial, I will see what is 3x square upon x. This I can do very easily because both are monomials. So x vanishes with this square and I am left with 3x. So next thing that I will do is, I will consider 3x into x plus 1. So this actually gives me the answer 3x square plus 3x. Now I will try to figure out this term in the expression that is given in the numerator. So if I want to figure out the expression that is given in the numerator, I can easily split this 4x as 3x plus x. If I can do so, that means I can take this term, and based on this logic, I can actually write this as 3x square plus 3x plus x plus 1 upon x plus 1. Now I can intelligently split the term over here and I can divide this, and I can take this as a separate term and divide this. So now you can readily see the answer will be here 3x into x plus 1, that will get cancelled off with x plus 1, and over here it will be 1. So the answer is 3x plus 1. Therefore such a division is possible. Okay. Let us verify whether the answer is 3x plus 1. Yes. So I have demonstrated you how to divide a polynomial using simple method by the method of factorization that we have already used. Now this is because x plus 1 was the factor of 3x square plus 4x plus 1. What if x plus 1 is not a factor of 3x square plus 4x plus 1? What would have happened? Let us use this example to understand our findings. So let me take an eraser and let me write that this, instead of 1, let me put, let all other things remain constant. What makes it a factor? That x plus 1. So I will simply, what I will simply do is, I will simply change the term to 4. Okay. Now x plus 1 is no longer a factor. Still I will continue with the same method. I will take this 3x by x. So I can consider this x square plus 3x. Only difference is this will be x plus 4. In that case, what happens is 3x square plus 3x. So that will give me 3x into, let me rewrite this as, into 1 into x plus 1 plus 3 upon x plus 1. So that again gives me an edge, that is, this is nothing but 3x plus 1 into x plus 1 by x plus 1 getting cancelled. So this will remain as 3 upon x plus 1. So this is how, even if it is not a factor, I can divide the polynomial. Now as we have started by giving some, for addition, multiplication, subtraction, we have given some algorithms. So now we need to identify such algorithm for division of polynomials. To do that, let us first solve this complicated problem in this simple manner and try to derive an algorithm try to derive an algorithm for by solving this problem. So the problem is, I want to divide the terms, divide a polynomial x raised to 4 2x square 3x plus 2 by qx, which is x square plus x plus 1. So the px is a polynomial of degree 4, qx is a polynomial of degree 2. So how will I go about this? So again, I will apply a same strategy, that is, I will start by writing x raised to 4 plus, remember here it directly goes to 2x square. So but I want the term containing x cube also to be present, x cube plus 2x square plus 3x plus 2, and this term is divided by x square plus x plus 1. So remember, our first step in the last example was, first you take the first term over here and take the first term over here. Then consider a division of these monomials. This will give me x square. So what I will do now is, I will consider x square into x square plus x plus 1. This will give me actually x raised to 4 plus x cube, x raised to 4 plus x cube plus x square. Now, as per our earlier strategy while solving this problem, we have adopted a strategy that I will add these terms over here. So if I add these terms over here, then I will subtract appropriate terms over here. So in this case, x raised to 4 is already there, x cube was not there, and here x cube is there. So I need to subtract that x cube from this expression, and then I need to subtract from 2x square. I will split this into 2. So let us rewrite this expression, that is the numerator of this expression. X raised to 4 is already there. In order to cancel the denominator, I need x cube over here. So I need to add x cube plus x square. Okay. But this x cube was not present here. It was 0 times x cube. So naturally, the next step will be to eliminate x cube from here, so that it will retain a legacy of this term. So if I have eliminated x cube, then it is 2x square, of which 1x square I have taken out. So this will be another x square, plus 3x plus 2 as it is. So let me write that term as it is, 3x plus 2. And now if I divide this term by x square plus x plus 1, then what I will get here is, take these first 3 terms and keep the remaining term as it is. Okay. So if I do that, then what will happen is, this term x square will come out as common, plus, now what happens, this term vanishes, this term vanishes, this term, because x square I can take out common, from these 3 terms I can take out x square common, that is what I have written, and it cancels with the denominator. So whatever is remaining are the remaining term, that is minus x cube plus x square plus 3x plus 2, and this thing is divided by x square plus x plus 1. Now is our division over? No, because the numerator over here has a higher degree than the denominator. Therefore, our division is not over. So again, I will follow a similar step. I will simply change the color so that I will have a better view. Okay, so let us change the color and have a better view of this. So let me write it here. From this step I can go here and say, okay, so this is in fact equal to x square plus, now you look at this term, minus x cube and x square. So you divide minus x cube by x square, which will give you minus x. So in this case you will multiply minus x with x square plus x plus 1. So if you multiply minus x with x square plus x plus 1, what you will get over here is minus x cube minus x square minus x. This is what you will get. So you write this term as it is, that is minus x cube minus x square minus x. Now from this term you adjust the terms. So minus x cube is already there, so I don't have to compensate for this term, but there is a plus x square, and here there is a minus x square. So that will give me plus 2x squares, because I am compensating for this extra minus x square added in this term. Then there is a minus x, and over here it is plus 3x. So I have to add one x for this minus x. So that will give me plus 4x plus, and there is no competition for a constant term, upon x square plus x plus 1. Now you can take out x common and this will cancel off. This term will cancel off with this term by taking x common. So it is x square minus x is in common, plus what you are left with here is 2x square plus 4x plus 2 upon x square plus x plus 1. Okay. Again you will apply a similar procedure, that is you will actually divide 2x square by x square, so you will get 2. So essentially what you so when you do that, when you divide 2x square by x square, you will get 2. So when you will multiply this number by 2, let me write it here, that is 2 times x square plus x plus 1. So in this case what you will get is 2x square plus 2x plus 2, of which 2x square is already there. So I will continue over here itself, x square minus x plus 2x square is already there, 2x square, so let it be 2x square plus 2x. Over here there is plus 4x, so I can split 2x over here, plus 2x plus 2, so that will again come plus 2 as it is here. So what is remaining now is 2x upon x square plus x plus 1. So now if you look at this term, what you will get is, you can take out 2 common and this will cancel off with this denominator, and therefore the final expression, I am running short of space, so let me erase some terms over here. Let me erase some terms over here so that I will get some space. So you can rewrite this as to be equal to x square minus x plus 2 plus 2x upon x square plus x plus 1. This will be the final answer to this division. Okay. So this is how we can actually do a division of two polynomials. Okay. Let us remove this and see whether verify whether we have got the final answer to be correct or not. So I have removed it. You must have noted the answer, and the final answer that we have got here is x square minus x plus 2 plus 2x upon qx. Qx is x square plus x plus 1. Yes, so I have got the correct answer. So here, while doing this, we have derived one algorithm which we will emphasize in the next slide.